Hi, this is the University of Pennsylvania team's entry for the 2021 SPARK virtual competition. This is our team. We have members of the team from multiple functions within University of Pennsylvania. We have people from earth science and geochemistry, environmental science and finance, and chemical engineering. This is the summary of our project statement here. So the problem is, how do we reduce residuals in AquaClara plants, and what do we do with the waste from the plants to deal with it in a more sustainable way? And our recommendations are to first introduce a new coagulant that will reduce the amount of solid waste. Two is to reuse the water by introducing it to artificial wetlands so that it can be reintroduced into the ecosystem. And three is to use the solid materials, the sludge, from the effluent as building materials in local communities.
So one of the ways that we can reduce the amount of sludge produced in the plant is using a different coagulant. We looked into using rare earth coagulants, specifically lanthanum and cerium. These will improve on current polyaluminum chloride coagulants in use, as they are heavier and form more polar bonds with oxygen. The stickier coagulant will help form larger and heavier flocks to be filtered out and sink quickly to the bottom of the tank during flocculation. This reduces the amount of sedimentation that moves on. They also are more attracted to phosphorus. This is important in the Gracias plant, as the influent comes from rivers full of phosphorus from nearby agriculture runoff. Since the flocks separate out faster, they will have less water and the overall sludge volume will decrease. We recognize more research needs to be done into which coagulant would best reduce costs and fit with individual plants.
To treat and then reuse the liquid waste from the sludge, we propose the use of a ridge bed system installed along with constructed floating wetlands in a stabilization lagoon. The ridge bed system would dewater the sludge with transpiration of water absorbed by the aquatic plants, and by filtration in a sand, gravel, and clay filter, thus separating most of the solid waste from the sludge. The liquid portion of the sludge then would be redirected to a stabilization lagoon, which has constructed floating wetlands. The aquatic plants this time would improve the water quality by absorbing pollutants and boosting organic matter decomposition with the microorganisms associated to its fruits. The treated liquid could then be reused in AquaClara treatment plants, or more safely disposed in the environment, as the concentration of aluminum flocculant would have greatly decreased. Studies showed that constructed wetlands, when appropriately installed, can decrease mosquito larvae populations in stationary water, so mosquitoes wouldn't be a major concern. This system would also have low maintenance and implementation costs, as it would be mainly constituted of native plants, gravel, and sand. To reduce costs, we also should suggest the reuse of waste materials for the construction of the floating wetlands. Finally, we propose a design in which there would be no macrophytes in the portion where solid waste would be accumulated, so that the water could be easily removed and then recycled. Because of time constraints, no quantitative estimation of cost and dimensions were provided in this presentation, but we would be happy to answer any questions about that.
The third and final approach is to recycle the dewatered sediment from the sludge and turn it into building materials such as bricks, roof tiles, or cement, depending on the exact composition of the sediment. Given the Honduras's tropical environment, kaolinite clay is likely the dominant grain, which would be the most suitable for brick making. Literature suggests using about 15 to 30% of wastewater treatment sludge in brick making and the rest of the original raw material to produce high-quality bricks. A substitution to the raw material could be mining slag or ash. AquaClara could try and fire the clays on site to produce bricks to give to the community, which would tackle its waste accumulation problem, or partner with local entrepreneurs that could take the raw clays and start a brick-making business, therefore creating jobs as well. This is our three-step solution. Try to reduce the amount of sludge generated by looking into more efficient, albeit more costly coagulants. Reuse the water present in the sludge by setting up artificial wetlands and allow the water to re-enter the ecosystem. And finally, recycle the sediment from the sludge into building materials to tackle the waste accumulation problem. Thank you very much for listening to our ideas, and we're happy to take any questions.